Okay, in this item, we're going to draw the free body diagram of member ABC in its simplest form. Now note, we have this cable that wraps around the pulley, and we're going to assume that the diameter of the pulley is negligible. Negligible. Why? Well, because look at the dimensions here. We don't know what the pulley size is, and if we don't know what the pulley size is, it makes some of these dimensions, the exact dimensions or the angles of the cable on either side, a little goofy and weird and not so certain what's going on there. So that's why we pretty much have to. We don't have enough information to do anything except for that. Alright, so here's our bracket A, B, C. And we can start off saying, well, I don't know what's simpler and what's not, but what I do know is we got a 75 Newton force. We have the cable ADC. It has to be in tension, so pulling away from the free body, it's going to have to be the same on both sides. And we've got then BX and BY. Now, T up at C is going to the left, so that means BX has to be going to the right. And I think the resultant of the T and the 75 is still vertical, and this T is horizontal. I think these things, those two have to pass through point D. Now that's why I say we neglect the diameter of the pulley, because that point is somehow lower than that where that force is at. So I guess you could argue that 75 and the cable force has to come up here. It really doesn't matter where that point is at. We have to intersect right up here. Again, ignore the diameter of the pulley and then don't have to worry about these kinds of things. But look what's going to happen. BY is going to have to be going down, and because the resultant of BX and BY must follow the straight line that's between B and C. This is a three-force system, in other words. Force down here, a net force that's different than the one here. Their lines of action intersect at D. These two resolve into a single force, three-force system. If those don't, then when I sum moments about that point D, that whole thing is going to somehow spin. So the simplest model, I guess, let's just put it into a tight little answer, is going to look something like this. I'll have some sort of net force here. Don't know what it is. Have a net force here. Don't know what it is. And I'll have a net or resultant force at B like this. That would be at B and T up at the top, and this will be 75 minus T down here at the bottom.